Now here you can put revision number or revision number date, and here suppose issued for review to generate this report. So drawn, checked, approved. So all these fields you can fill here and then click OK. So when you will click OK, then this type of screen will appear here. Okay, so you can see we have created in the previous lesson, we have created two numbers transformers connected with this switchboard MCC001, and this transformer is under operation. And now what we'll do, we'll left click, select this MCC bus, and then right click, then new circuit. So from this option you can create a new circuit for motor, heater, lighting, switchboard, transformer, line feeder. So anything you can draw from here. Suppose here also under motor you can see a lot of options available over here, whether it is circuit breaker and contactor operated, or whether it is only circuit breaker operated or fuse operated, star delta, dual starter. So all our options are available over here. Let's select this one. See, this will come. This is the motor feeder. Let's double click here. Okay, so now you will see for this circuit you can rename also for this. Suppose MCC001 M1, that means motor 1. It is connected with upstream MCC001, supply normal, conductors we can select 3 pole or triple pole neutral, but for triple pole neutral it is showing error. Anyway, we can select triple pole also, and if we select triple pole, this will be selected. Then designation here, this motor designation we can suppose cooler pump motor. Description here, type, whether this feeder is ACB operated or fuse operated, and type of fuse. So from this drop down list we have to select. Suppose I am selecting here this fuse operated. Here on circuit or downstream, this is on circuit. And for the second option, downstream, suppose if any motor is VFD driven, then on the downstream network we will use one type of protection, so that the upstream feeder, that means the feeder which is connected with the main power supply board, there should not be any protection, or to avoid the duplication. So only one protective device is sufficient for this single device. So here on circuit, now the cable data we have to put here. Cable length, suppose 50 meter. Cable whether it is PVC or XLP or any other type of cable. Let's keep the same. XLP 90 degree centigrade, CPL class, no need. Conductor, copper, aluminum. Okay, copper. This installation procedure. Perforated tray, no. Let's say on ladder. Installation method doesn't. Okay, ignore. Okay, whether it is multi-core, single trip foil. Let's say multi-core. Okay, here you can see the factors: temperature correction factor or group dating factors, and total correction factor. It is, if you have the data, you can put, and the total correction factor will come here, 0.78. So depending on the installation procedure and other factors, so this factor you have to consider. And here this will come after calculation. Before that, let's move forward. Here the motor rating you have to specify. Let's select. Okay, from this drop down list, can select, suppose, let's say 37 kilowatt asynchronous motor, and it's the factor. This factor by default it is 0.9. You can use 0.95 or even 1. Here is the power factor. You can change the value also. This is running power factor, and this is starting power factor, 0.3. Delta U, this is the voltage drop, maximum voltage drop for lower rating motors. Suppose for 11 kilowatt 5.5 kilowatt motor, generally it is 9%. And for this, suppose I will, okay, for this I will limit is to 5% maximum voltage drop. And here you can see this ID by IN is the locked rotor condition compared to the normal rated current. Generally for 5.5 kilowatt or 11 kilowatt motor, it is 9, and for 37 or 55 kilowatt, let's say it's 7 or 8 also. So that will be defined by the manufacturer data. Here is the efficiency. You can change as per the manufacturer actual data. Okay, so now click here. Now all the data related to the equipment and the connected cable, switchboard, those are given. Now let's calculate. Okay, here you can see single core 35 square mm cable, it is showing. Let's click here. If you see number of conductor, if this is 1, then cross sectional area we have to consider 35 square mm. If you select 10 square mm cross section, then 2 numbers per phase, 2 numbers cable run you have to select like this. If you use 6 square mm cable, then number of conductor run will be 3. So this depends uh, mainly on the manufacturer's data. Suppose for this motor terminal box, and depending on the installation procedure, installation situation at site, depending on the cable tray or the cable routing arrangement, this 35 square mm cross section is not possible there, or due to the terminal box unavailability, due to the unavailability of the provision to terminate this single this size of cable, maybe you need to consider lower cross sectional cable, but in that case the number of cable will be more. So this will be finalized based on the manufacturer's final input, and this is the preliminary calculation you have to select from here. So now click OK. Okay, now here you can see conformity sheet. If I click here, then this page will appear. Okay, here you can see these are the defined values, whatever we have defined based on the available inputs. And this side you can see cable voltage drop maximum del u maximum 5%. We have defined 5% limit, and in our case it is 1.26 percentage, which is within this 5% limit, so this is okay. And next one, this is the starting voltage drop, which limit is 15%, and as per our calculation it is 3.42%. In some cases, in some projects, it is defined that this starting voltage drop should be limited within 10%, but here in this software there is no provision to change this 15% to 10%. You have to check this manually, so you have to compare this as per calculated value with this 15% or 10%, whatever may be in your case. If you see here this sizing condition, this sizing this maximum protected length, this is 248 meter. So that means up to 248 meter this cable is protected. uh, this much of cable length can be used uh, fulfilling the uh, running voltage drop and starting voltage drop and the continuous current rating requirement. Here we have used this length as 50 meter, is 50 meter, but it can be used up to 248 meter maximum length. If it exceeds this 248 meter, then you have to calculate once again. You have to run this program once again considering the length. Otherwise, suppose your length is coming, instead of 50 meter, your length is coming 100 meter, or up to, or suppose 200 meter, then also the same cable size you can use for this particular feeder. So this is the conformity set. Let's close this one. Click OK. Okay, so now you can see 37 kilowatt 50 meter 3 core 35 square mm cable. Okay, now suppose you want to add more number of feeders, so double click here, go to new circuit and select here uh, suppose board. Okay, suppose from this switchboard, this there is a power supply feeder going to this db. Let's double click here. The same manner, we can put the same features over here. Suppose triple neutral. Okay, mccb, let's say it is mccb, and then on circuit cable length, suppose 100 100 meter XLP cable, copper conductor, not perforated, on cable ladder. Suppose this is single trefoil, all this related factor, let it be there. Power rating, suppose 10 kilowatt. Power factor 0.8, and voltage drop, maximum voltage drop, suppose 2% instead of 5%. 5% for motor feeder, we will define this feeder as 2% maximum voltage drop. Let's calculate. P conductor earthing network, equipotential bonding. Okay, so here we have selected triple neutral. Here you have to select equipotential, small fixed cross section. Okay, sensitivity on. Okay, so now you can see if 10 square mm cross sectional cable we want to use, then one number of conductor. If it is double run, then 6, like this. Click OK. Okay. Let's see. Let's add another one. New circuit for heating element. Just double click here. Suppose this is triple pole neutral. Designation cable length 20 meter. Copper. Ladder 0.78. Suppose this is 2 kilowatt heater load. This factor will be 1. Power factor should be 1. The max, let's define to for 5%. Calculate. There are a lot of errors are coming, but ignore for this cable sizing calculation, because this software is not only for the low voltage cable sizing calculation. This software is also for the uh, coordination, uh, relay setting and protection coordination system. That's why this type of alert or errors are coming, but don't worry for that. This will not impact the cable sizing calculation. So here you can see single run 2.5 square mm. Okay, so if you see this conformity sheet, here you can see this 5% maximum voltage drop, and in our calculation it is coming 0.56%. So this is okay. Let's close this one. Click OK. Okay, so this color is in pink. Let's double click over here. Triple pole. Let's say this is Stephen basic protection. Let's say 10 meter length. One kilowatt load. So this is showing an error. Let's check this feeder once again. uh, let's change this protective device here, fuse, and calculate this fuse, 2.5 square mm. Okay, okay, now the error is eliminated. So this is fuse operated. So this is the single line diagram I have modeled over here. So you can add up to any number of incoming or outgoing or coupling bus bars or feeders or drives equipments. And the main thing is to model this as per the project requirement. Then everything will be very easy to update or modify. So so up to this, in the next session I will share about different types of single different types of representation of this single line diagram along with the results and outputs to hand over to client.